This is Martin Carlisle with keygen Me 2 from pico2018 2018. The software has been updated. Can you find us a new product key for the program in this folder? We have a hint here that talks to us about Z3. So Z3 is a constraint solving tool from Microsoft Research, and there's a nice Python interface for it called Z3PY. Here's a GitHub page that talks about how to install Z3PY on Windows. I've done that here. And I've downloaded this program and I have it here in Ghidra. So in Ghidra, you will see that we have the check valid key. So just like with keygen Me 1, we're looking for a 16-byte product key. And you can see from check valid key that we're going to check our characters. They need to be 0 through 9 or capital A through capital Z. And we're also going to validate the key. And that validating the key is going to go through, and it has these constraints. So there are 12 different constraints going from 0, 1 to 12. And these are methods. And I'm going to translate each of these into a program in Python. So we have a 16 character array. And so I've created variables. So from Z3 import star is doing Z3PY. I'm creating a solver. I've created variables. I'm using bitvec32, so these are going to be 32-bit values that behave like machine integers. I'm naming them C00 through C15. And one of the things that I know is that they're all going to be mod 36. And I know that from the executable. We also saw this in keygen Me 1, that there's this method called ord. And so for 0 through 9, it subtracts out ASCII 0, and those are going to be 0 through 9 correspondingly. And then A through Z are 10 up through 35, because it subtracts off this hex 37 from A, leaving 10. And then it will go up to 35. So we have a 0 through 36 ring there. Or 0 through 35 modular ring mod 36. All right, so now we've created these 16 variables. I've named them. They're 32 bits. And I'm going to add in the constraints. And the constraints are going to come from the program itself. So if I look at key constraint 1, you'll see it looks at the 0 position of the array, the 1 position of the array. It adds them together mod 36 and checks to make sure that the result is hexadecimal E. So in my program, we add C0, C1, mod 36. We make sure that's hexadecimal E. We can then repeat that for key constraint 2. So again, we add them together, mod 36. This is positions 2 and 3 in the array, and it needs to be 18 in hex. 2 and 3, mod 36, 18 in hex. Each of them are similarly located. I'll show you key constraint 3 too as well, because it's a subtraction, so that one's slightly different. So there's the subtraction, and then the mod 36, right? There's the 36. That has to equal 6. Some more of them actually add 3 numbers together. So here's the 7th position, the 12th position, and the 13th position in the array, all added together equals 17 in hexadecimal. So I've done all of these together, and I've added all of these as constraints. So I have these 16-bit vectors, all of which need to be, I've got constraints that they have to be between 0 and 35, corresponding to that ord function we talked about. Then I have constraints for each of the key constraints. I'll print s.check, which will tell me sat, that the model is satisfiable. M will be the model, where it's actually assigned values to each of the variables. Then I convert those to a character. So a weird thing about the Z3 variables is to get them as integers, you first convert them to a string, which is how they would print out, and then convert them to an integer. If it's less than 10, I'm going to print out 0 through 9. Otherwise, I'm going to print out A through Z. And then I'm just going to print out the model for C00, the model for C01, the model for C02, etc. all passing that to toCharacter so that we get the results. So as I said, it's satisfiable. Here is the key that it's generated. We'll come over here. We'll put in that key. And there is the flag.